Welcome back to the last session for today after this coffee break. The last session was intended to be a roundtable, inviting our participants of the FormPlanet project to discuss, to show with all of you the results we get from the project. But pandemic changed everything in our life, we know, and we cannot have all our colleagues here. And we will have it on a streaming conditions. We will have it online. So we have 4 representative key players in the FormPlanet with us. Again, we will see now in the screen. Yes. Nice to see you again, all of you guys. Again, the pandemic changed it and changed our lives. And instead of a round table, we have a square screen. You should be here with us together, but we will be together soon. This is our hope. So let me first introduce all of our participants in this roundtable. The one on the top left is Michele Tedesco. Michele is the responsible for metals department in CRF, the Center Research of Fiat, now Stellantis Group. He is involved in the product development at the Stellantis business unit to introduce new innovative metal materials and support the team for the CIA virtual analysis. You saw Michele performing as a moderator, as a speaker today, so now we will have here as an expert in our table. At his right on the screen is Thomas Dieudonné. Thomas is a research engineer working at ArcelorMittal. He has a PhD degree since 2012. Thomas has been involved for 10 years in research and development projects regarding fracture and damage of advanced high-strength steels in Arcelor, covering topics as hydrogen embrittlement, crash ductility, and so on, topics that you have seen today during the session. Now back in the bottom of the screen, at the bottom left, is Ollane Cantero. Ollane has been involved in the steel industry since 2010 as a researcher, first in a steel making company, executing projects related to microalloy steels, high cycle fatigue, finite elements analysis. In 2016, she took the lead into the stainless steel world in Olarra. And since 2021, she is working in ARANIA, that is one of the FormPlanet partners working in cold rolling manufacturing. He is the materials and testing laboratory manager and depends on product and process technology department. And finally, on the bottom right of the screen, we have Bijish Babu. He is a PhD in material mechanics, nearly 2 decades of experience in material modeling and simulation of manufacturing processes. He is the director of the Aerobase Innovation. Aerobase Innovation is a spin-off from the Swedish Metal Research Institute and the Luleå University of Technology that focus on developing state-of-the-art materials models for manufacturing automotive components. He has coordinated and participated in many national, Swedish, I understand, and international private and public funded projects, and he's member of the European Materials Modeling Council. So thanks all of you for accepting the invitation for this roundtable. Today in the presentations we saw, the topics were almost following a similar trend, and I would like to ask you questions and give your opinion to these different topics we discussed today. I see that we have 3 main points. One point is how your company, how your business is taking benefit of the advanced material technology, the advanced material characterizations developed from FormPlanet, and not only for your business, but also how it affects to the relation to your partners and suppliers. I think that also a second point is how we see the future, how you see the future for your business regarding sheet metal forming. And finally, as we saw in the keynote lecture in this morning by Henrik Sjurin from Scania, life cycle analysis and sustainability is an important topic in the European today's industry. So I would like to ask you your opinion in all of these points. So let's just start with Michele Tedesco. You are representing in FormPlanet the car maker, the automotive industry, the final user of materials. So in general, the transport industry has been constantly asking for new materials for lightweight in the last 20 years. The vehicles are constantly changing the materials, looking for lighter and more or better performance materials. With a bunch of different candidates we have, metallic sheets are currently the preferred design option in automotive, as we also see this morning in the keynote lecture. So because metal sheets will be still be part of the volume weight of the vehicles on the coming years, can you explain to us, to the audience, how the tests that are developed and that you participate in FormPlanet help to the automotive sector to develop high quality parts with very high performance materials, and particularly how Stellantis is using these developments to interact or to better collaborate with material developers and suppliers. Michele, please.
Yeah. First of all, I would like to say thank you for the opportunity to participate in FormPlanet projects, in which I had the opportunity to know a lot of partners that are and can be also suppliers, all their industries that we can work together to develop the testing methodologies proposed by during the FormPlanet projects. As you said, the automotive industry is continuing to use and try to use new advanced strength steel and also aluminum alloys to reduce the weight of our car for two main reasons. If we are considering the internal combustion engine vehicle, reduce the weight is essential to reduce the CO2 emissions. While if we are considering the battery electric vehicles, reducing the weight is a choice, is an opportunity to increase the autonomy range. For this reason, also if in the future we will have electric car or internal combustion engine car, for sure we will look for new material to reduce the weight in all the cases. Taking the experimentation done in the FormPlanet, we would like to bring this experience and go forward and establish the base of the characterization of the new materials according to what we have done in FormPlanet. Because if we are able to predict during the simulation the failure of the material, we could save money, we could increase the quality of our product, and also talking a little bit about the last point that you mentioned before, we can give a great contribution to the circularity, to the CO2 emissions and so on, because we can scrap less component and so less material. So we can be more green than today. So it's essential for the automotive point of view, anticipate using the advanced methodologies developed during the FormPlanet projects, this information during the simulation. So anticipate the problem in the simulation and not found them in production.
Yes, totally agree, Michele. That was one of the points that we followed during all the FormPlanet execution. Back to the keynote that we had in the morning. One of the last points that Henrik Theorin stated is that we need predictable materials. So, Michele, what do you think about predictable materials?
Predictable materials means that we are able to know very well how will be the behavior of the material, and so trying to catch any kind of problem or opportunities during the simulation. Because if we have as you said before, predictable material, we can also try to optimize the use of the material, reduce, for example, the size of the blank, to use as maximum as possible the material that we have to reduce the scrap. And in other hand, if we know the material properties, we could also predict not forming behavior, but also the behavior during the crash, reducing also in this way the thickness of the material, because now we are taking some margin, safety margin. But if having a global picture of the material, we could have a clear view of what will be the behavior, we can also decrease this safety margin, and so decrease also the use of the material.
Yeah, I like this comment. It's nice to hear from your side, from an engineering point of view, that reducing the safety margins is safe because we are using predictable materials. If you materials that we can rely on, we can really optimize weight. I think this is the way to address lightweight construction in future vehicles. I agree with you, Michele. Now we talk about the steel, and here in our screen we have the representative of ArcelorMittal develop a key role during the FormPlanet, developing materials or apporting their knowledge in high strength steels for the transport sector. And yeah, I think that the steel sector generally, Thomas, I will ask to you this question. The steel sector is constantly evolving and adapting to the industrial demands for high performance materials for lightweight. In the last 20 years, when I started working in this topic, at the beginning, when the first trip and the dual phase steels were implemented here in SEAT in Barcelona, it has a big change in the materials portfolio that ArcelorMittal offers, and we see that the steel has an outstanding capability for lightweight, nice properties, toughness, strength, and formability. So, steel is still the material for lightweight, but I think that we are reaching a level that optimization is very difficult. Thomas, I would like to hear your opinion about how is the optimization in the steel industry. How do you think that the steel sector that you represent in this project may benefit from this advanced characterization developed in the FormPlanet project?
Thank you, Daniel, for the question. Nice to see you again. Yes, I have a first point to say about that. Regarding our R&D laboratory, we have here all the facilities available to characterize our steel grade at lab scale. But in some cases, our facilities can be overloaded or temporarily unavailable. So I think in this case, it can be very useful for us to be able to use the facilities of Eurecat, Contest, or LTU to characterize the formability or the crash resistance of our steel grade. In the second point, I would like to say that in some cases, it can also be useful for us, for our plants, and for our customers in Europe, for example, in Spain, in Germany, or whatever, to be in contact with these technical centers, so Eurecat, Contes, etc., which are geographically closer than us, and make available all these techniques of characterization can allow also to implement faster our materials with our customers, which have not always access to all these laboratory tests. And finally, just an example. For example, here in ArcelorMittal in Maizères, we are investing in the Helios 4 from Letomec, which is a non-destructive technique to measure hydrogen directly in the plant, as Linda Baki presented just before. So it is interesting to use this device, but work is still in progress to make the calibration of this device to can extend the scope to other materials than usable. And so for this, we are currently in discussion with Letomec on this topic to calibrate this device with other materials.
Yeah,
that's
a perfect example of how the collaboration in FormPlanet has been executing. And I'm also glad to see that the results we get here in Barcelona, results we get in France in your lab, so results we get in Luleå at the crash facilities in LTU are similar and reproducible. So it means that the industry and academia are going on the same way to characterize materials. Thomas, you also use the test to improve your modeling, right?
Yes, a little bit, yes.
Yes. What do you think is the improvement in the modelings in the models for crash specifically you have in the project?
Actually, I have difficulties to answer on this topic. I am not a specialist for modeling, so it is difficult to me to answer. But
yeah. Okay, we will find the expert. No problem, Thomas. You will get to us. Yes, thank you. Yeah, we can now. I would like to ask to Oiane from ARANIA, your experiences in the FormPlanet, because ARANIA transforms steels for applications where high formability is needed, deep drawing, for instance, or fine blanking. And in both cases, we need high formability, but different formability, not the same deep drawing than fine blanking. In both cases, we need nice, that the material flows properly and fractures properly. So the way that we identify formability, I think it's something that we developed new in the project. So I would like to see for you how you incorporate the test you develop in the project to better develop your process and even to look for optimized process windows. I think is one of your topics or your works during the project.
Yeah, that's it. So yeah, you're right. We manufacture cold rolled steels for deep drawing applications and fine blanking, amongst others. Regarding deep drawing, we have the basic steel parameters that are the planar or normal anisotropy and work hardening that are basically obtained through a conventional tensile test. The thing is that we wonder what would happen if occasionally we had to apply a modification in the conventional manufacturing process, let's say on the final skin pass due to fatness issues, surface quality problems, or any other unexpected manufacturing problems. We wonder if these modifications would affect in such a way those parameters that we would be having a problem in deep drawing operations. We realized that with the conventional test we had, we wouldn't be able to reproduce the behavior of the material in these deep drawing operations, and that we had to have access to additional tests that would replicate this behavior that's, let's say, more comparable to the one that our customers would apply. And these tests are the RDR and the earring tests that we successfully had access to thanks to the FormPlanet project. These tests have helped us better understand our products and be able to define a safe production process range while we could guarantee that our product would be meeting those deep drawing requirements. With regards to the fine blanking applications, as you say, it's a different behavior of material, but it's also critical to understand what the process within this fine blanking operation is. We had the situation where our customer told us that we had two material batches that had a different behavior, and they had been manufactured in the same way. Using the common or the conventional characterization method, this is optical microscopy and tensile tests, we didn't see any difference. So we need additional or discriminatory tests that would help us see what we couldn't see by the naked eye. Once again, this project has given us the opportunity to perform these additional tests that were essential work of practice together with electronic microscope analysis that we didn't have access to. Although in this case, we didn't really get to deepen as much as we wanted to due to the COVID-19 situation, we were able to see that thanks to these tests, we saw some differences that would really confirm that what our customer was saying about the product behavior of the material and the material that didn't have a proper behavior for the fine blanking operation, exactly, there were some differences. So all in all, I would point out that having access to this test bed has helped us, well, it has given us access to specific equipment or tests that we wouldn't have been able to have access to in any other way. And it has given us additional information about our product, and we have gained confidence when decision making. So I would say that this test bed represents a great option to cover the industrial needs in terms of unconventional tests, as long as timing and costs are adapted to the industrial day-to-day basis.
Yes, thanks, Ollane, for your opinion. That's true. That the test-based mission is to try to get this kind of tests that are not, I would say, standardized or easy to perform, so we can really help you and your customers or your suppliers to benefit. And as you explained, you use it very well for this collaboration with your customer. So that's we will consider also your suggestion about the cost and about time, because test beds must be efficient and predictable as we discussed before. Thank you, Ollane. And the same question more or less for Bijish, but a little bit adapted, because Bijish, you represent spin-off, a very small company. You are working in the modeling field of materials, so I guess that you need to have access to a lot of data in a fast and reliable way. So my question for you, Bijish, is how can a micro company or a spin-off, a small company as Aerobase, benefit from the testbed, and what would you ask to a testbed to do for you?
Yeah, right now, so thanks for inviting me, Daniel, and thanks for the question. Our participation in the project has been through this open call, and there what we did was to perform characterization of aluminium alloy to develop a model, a physically based model for damage and failure of a 7000 series alloy. What we did is we performed the testing at different orientations and studied how the failure happens and so on. And in this case, we have chosen two different heat treatments, an aged and non-aged, or as spent. So it has been quite a good opportunity for us to get into track to try out the possibilities within the FormPlanet, what is been offered. We had a brainstorming between different institutes and what they could offer, and for the characterization task that we had in front of us, what type of testing is the best suited. So it has been a smooth sailing, I would say, right from the beginning. From my involvement in the project, we could easily figure out what are the possibilities at the different European test centers, as well as the benefits and drawbacks of different techniques, and then we chose the most suitable one. And that is a very ideal situation for a small company, because we don't know really directly all the people involved and all the capabilities and so on. So that has been a benefit I see that could be beneficial for many companies.
Yes, you're right.
You
point that you're right that you participate in the open call, as Begoña presented this afternoon. So that's you think that I think you already answered, but you think that this interaction with the testbed was fluent, was nice, was as you expected? Of course,
yeah.
Of course, you have to say yes, but anyway, you can give your opinion.
Yeah, but yeah, I think it was quite smooth, and I see that's a lot of potential in the future as well to interact. The main possibility I see is that the capabilities of characterization and testing, they are evolving and improving day by day, and it's kind of challenging to keep up with which labs can do what and so on. So as a single window or a single entry point to get this access to this type of testing portfolio is a very good possibility for small as well as large companies, in my opinion.
Yes, I think that one of the points that we have to work from now on, because the FormPlanet is running from now, we have to adapt to different needs of large companies as Arcelor, Stellantis Group, ARANIA, and all the other partners, and also SMEs and also small companies as you. So I think this is one of the challenges that FormPlanet will face in the coming month. So I would like to change to the second block of questions. It is more about what is the future in your sector? How do you see? Because in automotive, for transport in particular, and sheet metal forming in general, I think that the coming mobility, the new electrical vehicles or fuel cells. I mean, I think that the future is interesting for all of us. So the first question of the second round is for Michele. You are representing now Stellantis. Stellantis is one of the most innovative car makers regarding the application of new materials. You were one of the first to introduce strip steels in the Panda, or the replications of quench and partitioned third generation high strength steels, and also sandwich steel sheet in Alfa Romeo Giulia and Stelvio. So I think that you are not afraid of using new materials in the vehicle. What do you think are the challenges for the automotive industry associated with the mobility scenarios, and how Stellantis will face them?
In terms of material, for sure, now the main topic that we would like to address are relating to the increase the passive safety. So introducing a new high strength material, and also decrease the weight as explained before. These are the main two outlook that we will see in the near future if we are taking into account the performance. But in terms of mobility, all of us know very well that now there is the transition between the internal combustion engine to the electric vehicle to reduce the CO2 emissions, or if it's possible, eliminate concretely this kind of pollution. So we are strongly involved in this, also in the choosing of the material to make the battery box, because it's a new component for the car. If we see also just 10 years before, we started to use aluminum as the main solution, the cast aluminum, but for the future, as explained by you, but we would like to test new materials. We are open to utilize the new kind of material, steel, aluminum, magnesium, why not? And for that, we have to work, because now we are in the comfort zone of casting magnesium, but we would like to go ahead, also reducing, if it's possible, weight and costs than the current solution. So the way is to introduce even new material for this kind of component.
Yeah, I like that you introduce a new material, magnesium, but it's not new. I mean, it's time to time is coming back to the table, but magnesium, we didn't talk about it today, but maybe it's a hot topic for the coming month. Michele, will you address, because in the audience we have a representative from all the value chain in the sheet metal forming. Do you have any recommendations for the sheet metal manufacturers to address these needs for new materials?
Yes, for sure. Because time by time, year by year, the importance of the pedigree of the material, the characterization of the material will take more importance to be more accurate during the simulation. So also when we would like to use a new kind of steel or a new kind of aluminum, is necessary to have all the characterization. So present the material with all of data that are needed to us to simulate this behavior, to predict the behavior of the component. And so the test bed maybe can support the smaller suppliers that has not so much equipment as the bigger one in the material characterization.
Yeah, I agree that approaching all the size of the value chain is really, really interesting to shorten the time to market for new products. You prepare me the perfect question for Thomas. It's about the pedigree of materials. But I will not ask this to Thomas to incorporate pedigree in the steel, but I understand what you mean, that the materials have to be traceable and has to be well known. Thomas, the question about materials, about the steel in the future in Europe, I think that the pandemic also evidenced that we need in Europe a strong supply chain. I mean, we have to minimize the dependency of critical raw materials. So I think it's not wise to apply materials that are really nice and exotic, but contains critical raw materials. And I think that in this sense, steel is having an additional point. So how do you think that the steel can help to build a more resilient European industrial sector?
Yes, thank you, Daniel. I agree with you. Of course, yes, availability of raw materials is becoming a key issue for the industry, a lot of industry. But we think that regarding the steel industry, it is a quite bit different, because since the beginning of the pandemic, we had no particular problem to deliver our customer, because we had a lot of demand, and we respond to the demand and we deliver our customer. But because in the steel industry, finishing line are already closed in most of cases, from final customers in each big region, like Europe, Asia, North or South America, and ArcelorMittal is present in all these big regions. So for us, fortunately, it was not a big problem, but we are not in the case of semiconductor, in which there is a big dependence of Asia, so it is quite different. But the second point is that ArcelorMittal is also an iron ore producer, and this is contribute to secure our production. And maybe I can talk on this point after, but this is also linked to the reduce of our CO2 emission. We try to have a better way to make steel with lower CO2 emission, and then also reduce the transport by boat or other. But there is also other solution I can explain after. But yes, of course, in the big market as automotive, the concept of circular economy is very important and will be more and more strong. And the recycling of steel must contribute, of course, to be less dependent of raw materials, because this is a very good materials to be recycled.
So yes, perfect. Thank you for giving me the opportunity to ask you first in the third round about sustainability. I will take the question back to you about that. Thank you, Thomas. Yanni, how in these times that the market is changing, how is ARANIA changing the materials portfolio? How is changing your markets to adapt to the new needs, electrical vehicle, and so on?
Sorry, I wasn't mute. I think we are all facing the common challenges that everyone is facing in the automotive industry. We are moving from the combustion engine to the electric one. This means that we have to identify all the parts. We have to struggle with identifying all those parts that are going to be modified or substituted by new ones. And we have to know what the requirements for those new parts are, what are going to be the raw materials that will be needed, what are going to be the requirements, the contact between the elements, the number of components, and so on, to have a good balance. And we are also working with the electric steels in order to be able to give the answer that our customers are requiring for this new trend of the electromobility. And what we've realized that we cannot depend exclusively on the automotive market, so we are working to develop our market under we are working to develop our market towards other markets, let's say like tooling, industry, agriculture, gardening, and see what can we offer our customers in those areas, and why not? We are also considering, or let's say we are having in mind the possibility of starting to work with different raw materials, let's say aluminum alloys, stainless steels, nickel-based alloys, who knows? And I think that pretty much summarizes what our working lines are.
Yes, that's nice to hear that you are active and ready to change if needed. So I think that the work in electrical steels is interesting in this case. So good luck with this. I think this is definitely very nice. Bijish, for you, the question about mobility is that from the modeling side, because you work in modeling vehicles and solutions. What do you think that the new mobility is bringing from a modeling point of view? I mean, do you think that crash testing for batteries has a special challenges that we should approach? What do you think is the coming times for modeling in sheet metal forming?
Yeah, I think this new sector for electromobility, it has opened up for us, or for the industry, is that it has opened up the possibility and also a willingness from companies to try out new materials and radical solutions. So it's definitely opened up the need and demand for doing more advanced simulations, either in the battery box or also even in traditional components. I think the part where I would elaborate a little bit more is what we had in our morning session when we talked about predictable materials. I guess the key there is that in order to have a more sustainable and improved life cycle utilization of the component and so on, we need to have components that last long and they can be upscaled or recycled and so on. The key is that with regard to a simulation point of view, to be more predictable is that you need to include the manufacturing process. But that's one step. It's many already do that, but it's not just enough. I think the key would be to quantify and include the stochastic variations of properties that arise during the manufacturing. How to include that in the modeling and so on, and thereby you can improve the predictability of a component or its in-service properties. I think that is to me a challenge or a problem that needs addressing.
Yeah, I think it's an interesting approach. Let's see how this evolves in the coming days. Back to the last points about sustainability. Thomas, you were really the volunteer for talking about sustainability. So the question is, of course, you can develop your answer about the sustainability or the life cycle assessment of steels. But I would like to especially ask to you, Thomas, that we know that steel, as you mentioned, is really a sustainable material, and Europe walks towards the industry decarbonization, definitely. So how do you think that the new steel grades will contribute to this topic, and specifically how ArcelorMittal will address the decarbonization of the steel industry?
Yes, thank you, Daniel, for the question. The first things I have to say is with ArcelorMittal, we have an objective to reduce by 30% our CO2 emission by 2030. And the second objective is to be carbon neutral by 2050 in the framework of a specific program which is called X-Carb. So here the objective is to produce standard and new steel grades according to this constraint with new industrial solution. And for example, in order to reduce our carbon print, one objective of ArcelorMittal is to increase the use of electrical arc furnace to be able to make steel from scrap material and reduce the use of blast furnace. This is one example. Another example is to develop iron ore electrolysis from clean electricity. So also use of green hydrogen produced by electrolysis with renewable electricity to reduce iron ore. Other example regarding the blast furnace is the reduction of iron ore by hydrogen, if this hydrogen is green. And other example can be the capture and the storage of carbon. So with when we use fossil fuels. So that's some example that we have for objective to use in the future to reduce our carbon print.
I think that one of the thanks for the interesting answers. I think that a side question for that or an opinion that I would say is that to the audience, if we have students or if you have your son or your daughter is going to study engineer, we will recommend, maybe Thomas you agree, study metallurgy. The future is not boring. I mean, we will have a lot of things happening in the steel sector. I think that you agree with this.
Yes, of course, of course. From my point of view, steel is the best material.
Yeah, we will not talk about the best of the world, but we
Because
talk.
it is yes, it is very fascinating. There is a lot. There is always. It is a very old material, but I think there is always to learn. There is. It is a material in constant evolution. Always to learn and always to improve the properties. So I think it is interesting.
Yes. So young students learn metallurgy. You will learn a lot of money working in the sector, of course. Michele, at the end you will pick the steel that is produced with this low CO2 and so on, and you will use it. We hope it. Then I think that that automotive is really taking seriously the sustainability of the materials you use. So Michele, how is sustainability issues addressed in the material selections in the Stellantis group?
This is one topic that is very hot in this period, and year by year our mission is to increase the percentage of metals, but not only, also polymers, that contain inside green percentage. If we are talking about steel, we are referring to the scrap. So we could be able to take the metals for the end of life of the vehicle and reuse it to make again the car. This is our dream. And for this reason, we are looking for to increase the green material year by year. Also anticipating what the European Commission maybe will commit in the next future. For that, the collaboration with the main supplier is essential, because we have to work together on the same direction. The suppliers have to produce the green material, and our mission is to implement them in our car.
Yeah, I think that definitely we have to change our mind as well and include sustainability issues when we select materials. So we also maybe need to better cover this from a testing point of view, or how we put a stamp of how sustainable is a material, something that maybe we can work in the future. Oiane, the last question for the round about sustainability is for you. How is ARANIA addressing these challenges in decarbonization and green industry in Europe?
Well, I think we have to close the loop. So what we can do, or what we are doing, is that we are analyzing what are all the stakeholders involved in this life cycle analysis. And with regards to ARANIA, all the sphere of influence that we have to consider is the raw material consumption and the transportation. And then within ARANIA, we have to analyze the energy consumption and the wastes we generate. So regarding the raw material consumption, we are starting to work with green certificate materials, and then regarding transport, we are making analysis in order to optimize the cost, transport, and timing.
Okay, so thank you, Oiane, for your contribution. So that was my last question. If you want to add something just to close this table, so Michele, Thomas, Leire, Bijish, if you want to add something.
Just thank you for this opportunity, and we have to work to continue to work together in this direction to have a full material characterization.
Yes, thank you, Michele. Of course, we have to work together and we have to meet again. The pandemics will not destroy the collaboration between the industry and the academia that we built during this FormPlanet project. So thanks to all of you for participating in this roundtable. Next time, presentially here in Barcelona, a nice dinner is from our side. Please remember me. Okay, so this is the end of the closing session of the seminar for today. It has been a It has been an intense seminar. It has been different approaches, different speakers. So I would like to close with some numbers about today, the summary for today. During this, from the morning to now, we have 5 technical sessions. I think that we touch the most relevant things in sheet metal characterization, the industrial challenges that the high strength are facing for us in Europe. We also address how academia and how industry can interact, can collaborate to progress through a more resilient and green European industry. This is where we live. We live in Europe, so we have to build a bright future for all of us. We contribute to this. Today we had more than 20 speakers. So first, I would like to acknowledge them, the participation, the preparation of the talks, the facilities, because it's not easy to be remote sometimes. Sometimes you have some technical problems or some misunderstandings, but I think that the session were fluent, and I will also acknowledge all the other people that work behind the scene that you cannot see here, that is responsible that this event has been a success. I think it's been a success because we had up to 2,080 attendees. I think this is it was a consistent number during all the sessions. So I think that this is a clear sign, clearly showing that the interest that the topic has for the industry from all across Europe. We have representatives from all the value chain in sheet metal forming for different countries, different sectors. So I think I'm really happy that the FormPlanet project ends in this way. So we started 3 years ago with an initial idea of bringing possibilities for understanding fracture and formability to the sheet metal factor to widespread all the knowledge we have, not only to big companies as Thomas and Michele explained before, but all the sector can benefit from this. I'm really glad that the project reached, as we see during the workshop, two patents, 2 CVA documents. We had different publications. We have a successful open call session. So I think that the project was very successful. So from Eurecat, we are proud to lead and coordinate this kind of academia and industry collaboration. Okay, the project as is funded by the European Union is finished right now. So, but the FormPlanet is not ended. FormPlanet just begin to work, offering services, offering collaboration to all of you from now. If you want to find out more, you have our project website here. You have also the site to download deliverables, to download and inspect all the very interesting case studies we have. You see the Catalina presentation from aluminium. You see the results that Michele present in hydrogen embrittlement in press hardening steels. You see the interesting modeling of crash and so on and so on and so on. All this documentation is ready for you at the project website. So please take a look. And if you have ideas, comments, and of course we are welcome to answer all of you. In the coming days, you, the ones that have registered to this seminar, will receive the video of the sessions. You will receive as well the presentations for those that has accepted to share the presentation. So in the coming days, you will have it. Because these works about fracture toughness, these works about metal formability, this is still going on for Eurecat. We are still working in this topic, and we will in the coming years, of course. Let me just show the upcoming events related to this topic. This is the Tough Steel Open Day. Is a seminar, is an open seminar that we will do online next week about how fracture toughness can be used in the sheet industry for understanding failures and formability. You saw today 20 minutes by David from it about this topic. Next week you will have an extended version of this. So if you're interested, click in the registration and follow this. Well, this is the end of the seminar. This is the end of the FormPlanet project, but this is the beginning of a new collaboration site for the sheet metal forming industry. Here you have in the screen the partners that make possible the FormPlanet. The partners are just this is the logos of the companies, but this is about 100 people behind this that work together. We should meet more often if pandemic allow us to do it, but we work perfectly well remotely, and the confidence and the collaboration was excellent in this project. Again, Eurecat as a coordinator, we are happy, and we are glad to see that this collaboration is going on. Just thank you again for the attendance. I would like to acknowledge the communication unit at Eurecat for making possible this event remotely. It is not easy. It would be better to have it all of you here in Barcelona. I hope you can do it. The end of May, beginning of June, we organize in Barcelona the CHS2 conference on high performance steel. So you are welcome also to be here in Barcelona and meet together. So yes, it was a pleasure to be with you today, and hopefully we can meet soon in the coming future. Goodbye.